Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Ellumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Ellumen's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Ellumen's website at www.ellumen.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hello. Hi, everyone. This is another edition of the AI innovation space. I have my co-host with me, Todd. Todd, how are you doing today?
Very good. Thanks, Yano.
Awesome. We're really excited about the conversation we're going to be getting in today. We have a really amazing guest with us, Keenan. Keenan is really passionate about automation, AI, robotics, cloud technology, and machine learning. And one thing I just really loved about Keenan and what he really brings to the table with regards to this conversation is that he has both the technical and the philosophical perspectives. And we're really looking forward to having a great conversation with you. Welcome, Keenan, to our podcast. How are you doing today?
Feeling great. It's Friday, so happy the weekend's here.
It was really exciting to realize that Backbox was working on some really great, interesting projects in AI and machine learning. You wouldn't have thought that, you have a team working on things relating to that. But before we get into the Backbox conversation, I just wanted you to do a little bit of introduction about yourself and what you've been working on.
Definitely. As you mentioned, I'm Keenan. I've been working in the data space for about 5 years now. And I have my master's in data science and AI specialization from Northwestern and my undergrad in psychology and computer science from Harvard.
Excellent. So we're going to go right to some questions around, Backbox. Can you share with us the overview of Backbox and what they do, the products and services that they offer?
Yeah, definitely. Bark is the most dog-centric company devoted to making all dogs happy. Founded in 2012, we've served over 6.5 million dogs across our history. And we're kind of come up with about 1,000 or more products every year that we design and manufacture and distribute. We have 5 key product lines. That's our BarkBox subscription box, which people are most familiar with. A Super Chewer, which is a line of toys for higher energy dogs that enjoy sort of tougher interactions. We have Bark Eats, which is nutritionist crafted food subscription plan. Bark Bright, which is our suite of health and wellness products. And then our retail side of the business, which supplies about 33,000 stores with our products.
Very interesting.
Todd, go ahead.
So yeah, it sounds like Bark has numerous products. So are you involved with contributing on a lot of them, or just a few of them, or how does that kind of work?
Yeah, so I would say we bring our products under the umbrella of the Bark brand, and we figure out the best way to sell and engage customers on each product line through our primary customer interaction devices. So for example, as I'm sure we'll talk about later, I work on the add to box model and the add to box capability. And so a lot of times to get customers interested in our other products, we use our very popular add to box, and we figure out what the best opportunity is to recommend them a product from there to kind of drive that cross product engagement or that cross sell engagement.
I see. Okay.
I see. So basically, are you gauging that based on their current interests? How does that really work?
We have some good signal on customers' current interest in surveys we take during customer onboarding. We also are consistently running, offline customer cohort analysis to see if we can cluster customers together, especially customers that we have a long tenure with, which means we naturally have more data and they are usually more engaged with the brand. Finding new customers that we think resemble them to figure out how we can best help them discover some of the other forms of the business. So we sort of take a multi-pronged approach, and in addition to leveraging marketing as much as possible.
That's super cool. With regards to surveys and assessment, what have you found to be some of the best approaches to gathering data through surveys?
Yeah, that's a great question. We're a little bit newer to our like customizing and personalizing a survey design based off of customer onboarding. But we find that the biggest determinant, one of the biggest determinants, I should say, of customers completing a survey or getting quality data sets from the survey is putting in the survey at the right time in the checkout process, getting them when they're the most interested, getting them when they are fully kind of engaging themselves with the brand. That's when we recommend to try to harvest that signal as much as possible. Beyond that, our happy team, we call it, which is our customer support team, is all in-house. So we have pretty robust customer interaction, pretty massive customer interactions when people, contact the brand directly. And we have classifiers that are live to help us understand each interaction and then use that to sort of feed what our knowledge is of each individual customer as well.
That's super cool. So, just thinking about that, I would just wonder, how did you end up at BarkBox? Why BarkBox?
Yeah, great question. So as I mentioned, prior to BarkBox, I was working at Accenture. I was working as a data scientist consultant, and I had entered Accenture with knowledge in the data science space. As I mentioned, I had taken classes on it as an undergrad, and I really loved working with data and with models. And I found at Accenture that the projects I most enjoyed were had a component of data science and software engineering. And I really wanted my work to persist outside of just the traditional Jupyter notebook, right? Wanted them to see what happened to the model after we developed it, after we, did our hyperparameter tuning, after we had an evaluation metric on a holdout set. And the MLE seemed like the perfect fit. I didn't know what it was a couple of years ago, but the machine learning engineers seemed like that perfect union. I was familiar with Bark. I had seen the subscription box, and it seemed like a very cool opportunity to work with product that brings people lots of joy, and also another great opportunity to work for a B2C company in the consumer goods space. Prior to Accenture, I had actually worked as a data analyst in a B2B role, and I had an idea that the B2C data set and the data problems you would solve for were very different than the B2B world, just based off of the volume, based off the diversity, and then but also based off of the end goals of basically what you're using the data for. Where in my B2B role, I might be trying to identify, customers that are about to churn, individual customers that are about to churn. In the B2C role, you're really looking for more like macro trends and influencing your overall strategy as a business rather than, doing individual target-based, churn prevention.
That is true.
I see. Yeah, very interesting. So can you kind of take us through what your typical day looks like at Bark? What is your life like being a MLA?
Yeah, definitely. So every morning when I wake up, I check Airflow. And for those who don't know Airflow, it's a kind of like a workflow orchestration tool to manage, maybe a Python job or a pod running in our Kubernetes cluster or a, data processing job in Spark. Basically just orchestrate major tasks. So every day I check Airflow for the DAGs, they're called, directed acyclic graphs, to make sure none of my DAGs have failed from the night before. And if they have, then go to fix them, as early as possible. From there, we have our ticket system and kind of get started on looking into how our models are currently doing. If we have any results back from purchase behavior in the ATV model or some of the other models I've worked on to make sure that we're not experiencing model drift. From there, I will usually spend some time working on our platform. The main component of our ML platform is to create a very accessible environment for our data scientists and for our machine learning engineers to be able to quickly iterate, create, deploy, and then redeploy models, feature engineering, etc. So a lot of work to be done there. We're kind of at the portion of that work where we're working on the inference side of things, which is very interesting. So that's usually how I end up my day, is a couple hours working on our inference capabilities.
I see. Okay, thanks for sharing.
Also, I was very curious about what you would define as, a great architecture for machine learning, right? I bet you guys have tasks or problems that machine learning solves in your organization. What would you define as very, a standard machine learning pipeline?
I'll describe. This is my favorite part of the job, but I'll sort of describe what Bark looked like when I joined versus what I look like now. So when I joined, the lifecycle process looked different. We were using, and we still are using, the best open source technology, which I think is kind of one pillar of the answer to your question about what a good infra looks like. If you're, a smaller company that isn't building out your own massive tools in house, then use open source technology to start. So we were using Airflow at Kubernetes, as I mentioned. We were using a deployment called Kubeflow, and we're a Docker first company. So we had all the right components of the model lifecycle, but they were often executed across different environments.
Exactly.
One model might have feature engineering in Airflow, hyperparameter tuning and training in Kubeflow, and then serving in a batch Airflow DAG. Another model has data engineering and training all in Kubeflow, and serving with like a fast API deployed to a Kubernetes pod. And so you can use the right technologies, but if you lack the consistency, then you'll run into problems down the line. And so one of my big goals was standardization, to provide a go-to infrastructure for repeated development and production of each step in the model lifecycle, in addition to separation of the components of the model lifecycle. For example, if my training job keeps failing, it should not also take down the capability of doing feature engineering, or vice versa, because we don't want to limit ourselves. We don't want to provide any hard stops, basically. This was a broad team effort at Bark. I'm just one member of a broader team. With this migration, we've already seen less outages, more visibility, much faster onboarding, and the ability to quickly deploy and develop new models and iterate on them while they are live. So I would say the first thing of a great infrastructure is leveraging all the available technologies possible. If you have a problem, odds are someone has solved it in some capacity, and it's more figuring out how to get it up and running than it is about developing yourself. I'm a big proponent of find or buy versus build for the right company. The second thing is consistency of environments. As a rule, you should say, if we have this specialized platform for feature engineering, this is where everyone should do their feature engineering. This is where you have to do it to create legitimized data sets. Anything else is not like a legitimized. So if you can kind of put a stamp of approval when feature engineering is executed in a specific environment, that's very helpful to get people on board. The third thing is separation of the jobs, and that's sort of along the lines of like a microservices architecture. But everything should run independently. You should be able to scale up feature engineering without having to scale up training. And if one failure should not impact the rest of your jobs. Beyond that, the actual specific technologies you use, I think that's really dependent on what the team's comfortable with, what the size of the team is, and what their technical level is. For us, having a Kubernetes cluster and maybe deploying a couple Helm charts for specific things we'd like to try out is just the right amount of technical lift for our team. But for someone else, using SageMaker or Google's Vertex AI exclusively could be a more appropriate solution. So that's probably the last thing, is to be honest with yourself about what lift you can take on as a team.
Right. And how do you decide that?
Yeah. I wish I had a better answer than trial and error. Trial and error. One thing we did at Bark, we were, just an anecdote, we were evaluating a feature store For those that don't know, a feature store is basically a product where you can store feature sets, store features that can be ready for training or inference. Basically, think about being able to call a service that provides you with all the latest features or up to a certain point in time and use them for training or inference with confidence that you're not introducing time-based bias into your model. So we were evaluating feature stores and we evaluated most of the popular ones. And we just really found that the footprint that they would create on both our workload and our maintenance, et cetera, wasn't worth the capabilities. We only needed one or two kind of simple capabilities. And we ended up going with something a little bit more in-house. So I think that a POC is always helpful. Try to have some of your engineers spend a week or two building out a use case and then give you their honest feedback as to how challenging that was and how hard it would be to do at scale. That worked pretty well for us.
So I know one thing we definitely wanted to dive into today was, getting some more details on this add-to-box recommender system and how machine learning is being used to help improve that system. So can you kind of share some details on that?
Yeah, absolutely. Our add-to-box recommender system is part of a very broad opportunity and focus on cross-sell within our multiple lines of business, as I mentioned. Add-to-box, essentially, customers every month or throughout the month can add on additional products in fun toys, treats, essential items. They can be added as a one-time purchase or a cumulative subscription. And at its core, Add-to-box is very much like a web page real estate optimization problem. How can we recommend the right SKUs to each customer at the right time? Cognizant that if a customer can only see so many products at once, and featuring something like X could potentially cannibalize Y. So there's lots of questions to answer. Do we prefer long-term engagement SKUs, maybe something that doesn't net quite as much revenue, but will keep our customers, it'll be more sticky for our customers, will prevent churn, versus just immediate spikes in revenue for our high-price add-to-box items. There are SKUs that help engage with other business lines and SKUs that can drive organic marketing, which is also definitely a consideration. And then beyond just pure machine learning, which I can dive into a little bit more, we use traditional data science techniques like A/B testing on all of our user experience and UI. We have a great, amazing cross-sell, upsell tech team that is constantly testing hypotheses, proving them out, iterating, and changing things. ML is essential to testing the recommendation strategy, and we use machine learning to solve different optimization goals. As a business, we may want to focus some months on generating maximum possible revenue. At another time, we may want to focus on driving as much cross-product engagement as possible. The approach that we found works for us in the recommender space is to test models live, test different models for certain customers, give them a general treatment, give them a specific type of model, and then see how they perform against our evaluation metrics. So without going too much into feature specifics or individual model performance, one model that we really like for our unique business case is the wide and deep recommender model. And it was published by Google researchers. And I think they used it on the Play Store. It's really apt for data sets that have both sparse features and one-hot encoded categorical data and denser continuous variable features like price and cost, or a dense embedding, etc. The nice thing about the model is that it balances memorization and generalization. With highly dimensional data, you have to be wary of your model just basically memorizing specific attributes to purchase outcomes. So this model does a pretty good job at balancing that memorization and generalization across the data set. And it's particularly good at circumventing the cold start problem. The cold start problem is where you have a new customer, you don't have a lot of data on what they've engaged with. You want to recommend them, the best things possible, but you also want to learn as much as possible from them. The reason it works well with the cold start problem is it uses basically customer and SKU attributes, which we might have at the time of new customer, rather than historical purchases. And like a traditional collaborative filtering recommender system, you recommend B and C if a customer engaged with A and they're similar to another customer that engaged with A. We don't always have that. It works really well for a service like Netflix or any video streaming service because they get a lot of customer interaction. People might engage with the service multiple times. But in Add-to-box, people are often purchasing things once or twice a month, and we have to use that signal as quickly and efficiently as possible. We don't get sort of lots of different content or lots of different SKUs that they've engaged with as part of a recommender system.
I see. Okay. So, you mentioned that was just one model. So I'm just kind of curious, like you don't have to give an exact number, but like how many different types of models are you guys looking at? And one other thing that I found was interesting from your earlier conversation was it sounds like you guys are kind of changing how the system is working based on, what you're trying to accomplish that particular month. So is there like a lot of back and forth with like the machine learning engineers and business development, or how does that process kind of work?
Yeah, that's a great question. I would say we don't change like month to month in our strategy necessarily, but per the first part of your question regarding the models we have in production, we're sort of entering the maturity level to be able to test across different models. We test hypotheses with usually like one or two models at a time. When we try out a different model, we're less often trying like a deep learning model against a ensemble methods XGBoost model. We're more testing overall strategy that's been implemented into the model. So where one model might recommend based off of perceived immediate purchase volume, another model might be the goal might be to optimize towards SKUs that we know drive long-term engagement with the brand. I would say it's more of like almost like assignment or SKU recommender strategy testing than just pure model testing. Because in theory, either model with the right optimization goal could achieve that business goal. So that's often what we're testing between those two variants. And then the last thing you said, our collaboration with our business development team is like really vital and really important to all the success, both in their ability to quickly test and iterate on front end changes, and also to give us feedback as to what the broader business wants to see become as an output from machine learning. And that's one of the things I learned from working on the ATB recommender system is kind of two core things: is that the interaction between personalized customer experience and machine learning is more important than ever. What works well for one customer might not work well for another. A lot of customers expect a personalized experience and brand engagement on their terms, and the only way to provide that through in scale is through machine learning and lots of data. And the second thing I've learned is user experience and machine learning should be really closely aligned in any digital commerce business. Our strong collaboration with our cross-sell upsell team allows us this rapid testing and iteration of new ideas. And these conversations can impact both how we make our models and how they test different user experience, user interface, that sort of thing. So that collaboration has really enabled us to test new ideas quickly.
I see. Okay, thank you.
How does your machine learning team interact with the other teams within the organization, right? Your UI UX team,
Yep.
your design team, like your front end, design team.
Yep, definitely. Great question. So I know that there's been some business like research, kind of MBA research on optimal data team formats in different size enterprises. And the two that I'll kind of default to is one is that you have basically a data team embedded onto every other team in the organization, and they sort of are the liaison between all things data, and they support that team that they're assigned with. And the second one is sort of a centralized data team that everyone goes internally. It's more of like a universe design where everyone goes internally to that data team for recommendations for projects, et cetera. So we're the latter. We have a centralized data team. We have a very robust data department that encompasses machine learning, data science, and business intelligence, and my role, machine learning engineering. But we operate as much as possible in the former, despite the organization being the latter, meaning we embed our data scientists with the teams whose problems they're solving for. And I think this is really important because in the data field, we can often lose perspective or lose scope of what the problem is just based off of looking at the data. We can sometimes exist in a silo, operate only on optimizing for a certain data set rather and lose focus of the broader business goal. So for example, I sit every week with our cross-sell upsell team, those front-end engineers and the product manager, and we discuss what new things they're working on, what kind of data they would need to be successful, and also they communicate back to me what the overall goals of the business are and how that should be interpreted if needing a model change, that sort of thing. So we operate as like we have an individual data team, but we all go out into the projects and we all support the teams whose problems we're solving for, which I think is really helpful and really important, especially in a business where data is supporting everything else, right? We want to support cross-sell, upsell. We want to support churn prevention. We want to support, new customer acquisition. Data is should help everyone, should support everyone rather than being the end all be all.
That's true.
Yeah, that's a very interesting approach on how you guys are handling that. So any challenges that you guys are facing with any of Bark's machine learning products and models that you guys are actively working on, or you want to share?
Some of the main challenges we might face are data drift, model drift, just pure class imbalance in our data sets, figuring out model explainability. Our solutions are usually oriented around test and measure perspective. And that's one of the nice affordances of being in a B2C business, is that you have usually massive customer base that you can test things on, understand if you're reaching statistical significance, and then, deploy the better variant. And Bark is amazing at it as a test first company. We test into almost all of our ideas and our new strategies. So one challenge we found with our recommender system is basically when we have our live model, right? And we have our live model and it makes recommendations for customers and they, choose to purchase or not. And that gives us our, training data for the next month. If we want to test a new model with different objectives, it's sometimes challenging to use the training data because it's been biased by the fact that the customers were recommended what the original model thought was the best recommendations. So the new model might perform worse on the data set because all of its training data is based off of what another model had recommended. And that older model might perform better because the prior data is biased to providing outcomes that are, again, in line with the original model. When you want to test new models, this can be challenging because you have to figure out what's a lesser biased data set that I can use to really evaluate which model is better offline. So our approach is to more figure out how can we do a live inference test, an online test between two models, and really weigh out which one is performing better across our key metrics, which one is doing better in production. That's just one example of where offline testing might be very challenging, but online testing makes a lot more sense.
The one last thing I was going to talk about is your work in the robotic space. How's that panning along?
Yeah, it's definitely interesting. It's definitely more of a personal hobby, but it's really fun to work on robotics. I have a project where I basically was toying around with OpenCV is this really powerful engine for computer vision and basically video parsing, and specifically what one of the models they have is called OpenPose. OpenPose can do joint and limb estimation, and so basically, for the layman, you can turn on your webcam and it can tell you exactly where your fingers are, your arms are in the 3D space around you. And I was playing with this in my master's program, and I really liked what I was seeing, and I thought the accuracy was amazing. And at that time, during COVID, I had just started picking up building, little robotic kits, and I happened to build one that was a robotic arm with a robotic hand. And I thought that the marriage between those two projects would be really interesting. Essentially being able to control a robotic hand with the OpenCV library outputs. Traditionally, controlling a robotic hand with a PlayStation controller would be very challenging because of all the different dexterity moves you could do with fingers, arm, etc. And so one of the projects I worked on during COVID, and purely a personal project, was setting up my gaming computer, and it has a pretty good GPU, and running OpenCV's OpenPose pose estimation. Basically, it was a Docker container, tying those outputs back to the robot hand and being able to control the robot hand with outputs from my webcam. That post is on my personal website, and on, I published it to Reddit, and I think it was picked up by Makers Fest, which is projects demonstrating projects that people do, in their spare time. And what I really realized while I was doing that project is that there's a really beautiful and interesting intersection between what is a very ephemeral space in data science and machine learning, oftentimes, working with everything digital, bits and bytes, and the physical space, bringing something into the physical world. And I realized that there's a very cool opportunity to bring our data science models into the physical world through things like robotics, autonomous driving, that sort of thing. And so that was definitely spurred my interest. And I want to continue to, study robotics as much as possible. I don't get to do much robotics work at Bark. It's definitely always going to be a personal passion of mine.
And it sounds like a lot of that was kind of spurred by some classes you took. if someone is interested in, being a machine learning engineer like you are, would you, recommend a similar path in school and college, or would you, make any suggested changes if someone was trying to pursue that as a career?
Yeah, that's a great question. To be honest, I don't think there's any one path to becoming a data scientist or machine learning engineer. I think we see lots of PhDs in lesser related fields translating really well into the data science industry because they have the academic discipline and rigor of doing, research for several years on a problem, citing their sources, coming up with a novel idea, and then publishing it. My suggestion would be that in the space of machine learning and in the space of data science, it's a lot of times it's the interaction between programming, statistics, calculus, and linear algebra. I would say that those are sort of the main tenets of at least the work I do. People often feel like they have to be an expert in every single one. And I don't always necessarily think that's true, at least in the modern world of data science and machine learning. Oftentimes, the interest and the will is enough to find success in this field. If you don't feel like you're the strongest in any particular subject, but at the end of the day, you really love doing it, then staying up till 1 a.m., working with the data set, preparing it, getting it ready to training a model, all night, that sort of thing won't seem as bad and it won't feel like work as much. So I would say the interest is really important beyond any kind of hard skill in the science realm. And lastly, curiosity is vital to this role.
I definitely see your passion come through about working on all this data. So, kind of just thinking a little broader, like, you've mentioned a lot of various interesting applications and even in, your personal projects with robotics. How do you see some of these types of solutions you've come up, maybe having some applicability in other types of applications and maybe solving other problems in other industries?
Yeah, that's a $1 million question. I would say that I don't have a perfect answer.
Mm-hmm.
One area that I've definitely become more and more interested in, and I've been thinking about recently, is the capability and the capacity for like a self-service machine learning, in the sense that can we create, something as simple as Grammarly is a great example. Grammarly, the customers are using machine learning every single day when they use Grammarly. They're using very advanced models, and it's helping with their writing and then helping with their grammar and spelling and et cetera. They don't have to, the consumer doesn't have to know anything about machine learning. They don't have to, purchase some enterprise product, but they're benefiting directly from an ML capability. So I think a great opportunity in the future is to figure out what ways can we embed machine learning in people's daily lives so that they either don't even know it's there, or it's so instrumental that if it requires some education, then it'll benefit them in the long term.
Excellent. It was just super amazing just listening and great conversations. Thanks so much for joining us today.
Thank you for having me.
This has been the AI Innovation Space, sponsored by Ellumen. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Ellumen website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us.